Anyway, so good morning again, and welcome to Areas of Application. My name is Gabriele De Canio, and together with Giuseppe Borghi and Domenico Mignolo, I will give the first talk of today's track, titled Transforming Space with AI, Operations, Earth Observation, Telecommunications. Before starting, let me remind you that you can ask questions on the Q&A tab at the bottom right of WebEx. And now I'm happy to introduce the two other speakers. So Giuseppe Borghi is head of the ESA lab, or the ESA Phi Lab since June 2020. The Phi Lab is a dedicated lab to accelerate the future of Earth observation. Giuseppe holds a PhD in robotics and artificial intelligence and a master's in executive general management. He has contributed for 22 years to worldwide space industry innovation, both in executive and managerial roles, exploiting technology and transformational innovation as catalysts for success. The other speaker, Domenico Mignolo, joined ESA in 2002, and he is currently head of a ground segment section in the Telecom and Integrated Application Directorate of ESA. In his career at ESA, he has initiated several system and ground segment industrial activities, public-private partnership projects, and programmatic initiatives in the framework of the ARTES program. Within his directorate, he is currently coordinating future initiatives related to AI under the ARTES program. So I think now I have set the scene, I have introduced the speakers, and I can start with my talk. So as mentioned, today I will talk about transforming space with AI, and I will focus on operations. So it is important to say that the European Space Centre, just to set up the scene a little bit, I just time myself. The European Space Operations Centre, which is located in Darmstadt, is home to engineering teams that control and operate the spacecraft in orbit, but also design and build the space systems on the ground that support missions in space and deal with space safety. This entails space weather, space debris, and planetary defense. Of course, as you can imagine, operating a spacecraft is a very complex task. Apart from the clear difficulty related to operating an asset that is thousands of kilometers away, space is also a very harsh environment. And this is one of the reasons why space mission operations tend to be conservative. However, given the significant potential for AI in space mission operations, HESOC has been carrying AI-related activities for quite some time. These were both internal and in partnership with industry. So in this slide, I'm just summarizing a few examples. What we have here is an AI application for moon landing site identification. And that basically entails using computer vision, take the images of the moon landing, of the moon surface, and then try to identify craters which are overlaid to the picture here. And you can see them as depicted in yellow circles. So these are all the craters or hazards. And this kind of activity will help and will support the identification of moon sites for the landing of future European, ideally European and non-European missions on the moon. Another remarkable example is on forecasting the tanks of XMM Newton, so one of ESA's flagship missions. XMM Newton has been flying for almost 22 years now, and that allowed us to have a lot of data to leverage and to use in order to properly model the thermal behavior of the tanks. And in this case, we used LSTM to make accurate predictions of the temperature of the tanks in advance up to 48 hours. This was I mean, long and short-term forecasting is a very key activity in operations, because it can allow us to really understand what would be the state of the spacecraft, and therefore take preventive measures that would allow the spacecraft not to reach a dangerous state for the spacecraft itself. Another remarkable example is actually with Mars Express, and using AI, and in that case, random forest actually, to predict, specifically random forest, to predict the battery consumption on board. And that took into account a lot of parameters ranging from the actual state vector, so position and velocity, or elements, as you wish, together with the umbra and other parameters, the distance to the sun, but also internal constraints. And this allowed to have a good planning, a good forecasting of what the battery consumption would look like, and therefore also in this case take preventive measures. We also have another remarkable example. So as mentioned, we have been doing AI activities for quite some time now, but we have also tried to engage with universities, with research institutions. And this is one of the reasons why a couple of years ago we launched a challenge titled Collision Avoidance Challenge on Kelvins. So kelvins.esa.int is a platform where we have all this type of challenges. And the goal of that very challenge was actually to use AI and specifically machine learning to predict the risk of a collision. That was a very remarkable example of engaging people that were not necessarily coming from the space sector, and the result was actually quite interesting. That being said, I mean, these are just some key topical examples of past AI activities. The list is actually quite long. However, despite having quite this vast set of activities that are related to AI already, we kind of realized that these were somewhat scattered and uncoordinated. So this is the reason why we decided to use a systematic approach and work towards developing an AI roadmap. And I'm going to talk about this in a second. The goal of the roadmap is to help us best focus our energy and efforts and set a clear direction to ensure that the activities we are running are aligned and are contributing towards the same goal. So, as mentioned, this is the idea behind going from a scattered landscape where we had a lot of AI initiatives to something that is a bit more structured and coordinated, so the AI roadmap. As you can see here, we have a lot of benefits that would emerge from implementing and rolling out such a roadmap. Of course, we have the element about reinforcing the topic of AI, as mentioned in ESA's Agenda 2025. So this is a document that was produced by the Director General when he took up his duty together with his team, and AI is very high in his agenda. But also this would allow us to support the ESOC 2025 strategy, so the strategy we are setting internally. But in addition, we also have a lot of very important benefits that should be mentioned. So first of all, the possibility to bolster the European space sector as a forerunner of AI in space mission operations. Of course, we also benefit by strengthening ESOC's position as an innovation hub. By leveraging AI, we will be able to increase efficiency and also to foster European growth in applied AI. So try to shift a little bit the main expertise from the US and China to Europe, and also increase industry competitiveness and AI know-how. So these are the benefits of the AI roadmap. And now I'm going to talk to you about how we created it, how we managed to get from the idea of having something coordinated to an actual roadmap. So the approach we followed was basically to set up a vision. This was set by the management team, so the board, that is setting up the what would be the purpose, the vision we wanted to stick to. And I will just read it out loud. So it states that by 2030, we want demonstrated AI technologies to enhance operational efficiency and enable twice as many ambitious missions by embracing fast iterations and by refocusing intellectual and financial resources. So this is the vision. And as you can see, there are three strategic pillars that are underlying it. So one is to have faster iterations in execution. One is to have a refocused intellectual capacity, and then redeployed financial resources. Of course, if we free up people from repetitive and mundane tasks, we are really able to have faster iterations, refocused intellectual capacity, and eventually have savings that can be used to enhance other aspects as well. So that being said, after setting up the vision, we actually had to perform a few steps to define it. The first step was, of course, to actually analyze the current state of the art and see what are the activities related to AI within our center. And of course, that took quite some time. As I said, we do have quite a long list of activities. And what we did was to map these activities to really understand where we were. So map the activities to the domains, map the activities to the outputs. The next step was actually to identify where we want to go, where we want to be in a few years' time. And that was the to-be analysis. The to-be analysis was very important because we followed a quite structured approach that allowed us to understand what would be the most important areas where the benefits can actually be foreseen, and therefore try to ideate domains and use cases that would really allow us to untap that potential. And then the first step was the roadmap. So from the SIS analysis to the to-be analysis, we need to go from point A to point B, and this is through the roadmap. After having defined the roadmap, which I'm going to show you in the next slide, we actually started rolling it out. And this was done through the development of a prototype. More information later. The bottom line here is that the roadmap is something we are doing and that would benefit the European space mission operations sector as a whole. For this, we wanted to engage a lot of people, internal from ESA, from ESOC, as well as industry. We sat down together and we ideated the use cases, potential use cases, identified key domains, and we brainstormed together. And eventually, we spent more than 150 hours in interviews and brainstorming, but we achieved the roadmap. About the prototype. So the prototype is a very key element of start rolling out the roadmap. And we needed people to support its development. So we now have 6 missions, 6 space missions that are supporting it and are contributing towards the development of the prototype itself. One of the key elements of the roadmap is the agile contribution and the fact that agile methodologies should actually be used. So this is just a snapshot of the AI roadmap. The result of these steps are these. We have identified 5 mission operations domains that, based on impact and feasibility, should be prioritized. And these are routine operations for flight control teams and ground stations, operations, preparations, and operational simulation, system testing and validation, ground system maintenance and ground operations, satellite health monitoring, and data processing. Underpinning these 5 mission operations domains, we actually have 7 AI classes that, for the sake of brevity, I just leave here, but I won't go through the details too much. This highlighted in red is actually the domain where we started rolling out the roadmap, and where the prototype is the domain that is related to the prototype we are currently developing. And now I would like to provide an overview of the prototype, because I think nicely fits with Professor Dengel's talk yesterday. He mentioned yesterday about knowledge graph and how powerful they are to take different data sources and create a mapping to retrieve information fast, to extend knowledge that go beyond the first level matches in the text may look like. So what we are doing here is the goal of the prototype is to develop an AI assistant to support the decision-making of the flight control teams. These are the people that are actually operating the spacecraft. This tool would take different data sources in. You see here, for example, flight operations plan, telemetry, mission control systems, anomaly reports, ground stations, and flight dynamics data. And by merging together this information, this is the timer, so I'm overrunning. I'll stop quickly. But by using different data sources, we are then going to have a good knowledge graph that people end users can use. And as I was mentioning earlier, we have this. We have 6 missions that are supporting, from the end user perspective, the development of the prototype. And this is actually very helpful in order to fine-tune both the UI, which is not the AI part, but actually based on the feedback on the matches and on the results produced by inquiring the knowledge graph, fine-tuning the underlying AI algorithms in order to have more accurate results that would result in better support and better aid to the operators. So thank you very much for your attention. I now leave the floor to Giuseppe Borghi, and I leave here my contact details. So if you have questions, feel free to reach out to me. Thank you very much.
Thank you, Gabriele. Very, very interesting. So let me start sharing my screen. And please let me know if you see my screen.
Yes, I confirm I can see it. Thank you, Giuseppe.
Thank you very much. So as Gabriele said, I'm Giuseppe. I'm the head of the FILAB, and I work in ESA since more than a year. So today I want to give you a sense of what is ESA FILAB and what are transformative changes that we are doing in this organization. So the ESA FILAB is a division of the Earth Observation Program Directorate of ESA. And our mission is to help and find a way to accelerate the future of Earth observation. And we want to do this, and we are asked to do this by a specific tool that is the disruptive innovation or transformational innovation, as is called in some cases, with a very precise goal. The goal is to strengthen the European competitiveness worldwide. So means make our research, our talent, our entrepreneur winning the worldwide competition. And the FILAB is a kind of strange organization in ESA because is doing this, so accelerating the future of this sector by managing the full innovation pipeline. So we really start from, let's say, discovering in our network of research of industry or university, blue sky idea, bright idea, or we develop idea internally to the Philab, and then we have the possibility to nurture, to mature, to develop this idea, down to, for the good one, to be able to support entrepreneur to enter into the market through our commercialization program. We do this by two offices. One is the Explore office that deals mainly with the initial part of this innovation pipeline, which is led by Mr. Pierre-Philippe Mathieu. And a second office, which is mainly dealing with the second part of this innovation pipeline, so the Invest office, which is led by Mrs. Amanda Regan. So we call this model innovate and apply under one roof, because we have in the same organization, actually in the same location, people that are research oriented. So we have a lot of research fellow, or let's say a team of PhD, and people that make business development or that make impact to the science community, all around, let's say, a single organization. So what's our vision? Let's think a little bit about what are right now the traditional Earth observation systems. So what we say, the current system have intelligence far from perception. So you see here some, let's say, of well-known Earth observation satellite, and down some users. And in order to generate, let's say, information and action or insight or knowledge, what is the process? The process is the data, the sensing is done on orbit. Then the data are downloaded on Earth, and these then they will go to HPC computer, in the future quantum computer, where I would say the magic is happening. So data are transformed in product and information, then delivered to the user. This is mainly a monodirectional process. So information come down, so data come down, become information, actionable insight, and a bit goes up, but not much. So what will be the next from artificial intelligence, cloud, and Internet of Things computing in space? So what we see, which is already happening, is that intelligence will go close to perception. So what does it mean? Means that intelligence will move from, in part, not all, but in great part, from being down on ground, on the Earth, to in orbit, on the satellite. And this is already, let's say, happening today. That's something currently under development, certainly demonstrated at technological level, now moving to operational satellites. So then there will be generated not data, but actually information. And this information then will be shared in a cloud network, an Internet of Things network in space. And this information then will be downloaded and merged with information generated on ground, making this a seamless integrated system of someone would call intelligent agent. So that's the direction we see where we should go in order to make transformative Earth observation. So what's the Philab actually? The Philab is located in Italy, in Frascati, close to Rome, and it's a quite recent organization. We have been established almost 4 years ago. We are about 30 members, just a third is staff. The rest are research fellows, staying with us for 2-3 years, and several industry and academia visiting resources, so people coming from industry, from other institutions that come to us, stay a period with us to create innovation. In terms of innovation technology, so what do we produce in terms of innovation technology in the Philab? Mainly we work around machine learning. Now we are extending to more artificial intelligence, like natural language processing, reasoning under uncertainty, and these kind of topics. The second axis that we have started last year is quantum computing for Earth observation. This is more, let's say, for the future, so it will take a few years to develop. And we are setting up a collaboration, European collaboration, to work on this. And as I said, we work on Internet of Things, also ledger, so distributed ledger, blockchain, and cognitive space. In terms of where do we deliver impact from this disruptive innovation is in each part of a space system. So flight hardware, flight software application, downstream application, complete system, end-to-end, or even innovative business model.
Giuseppe, you have one more minute.
Okay, so I will be faster. So this
you.
is just an example of what is, let's say, the seed that ESA has put on this vision of being, let's say, cognitive cloud space, which is the FISAT-1, which has been launched the last year. And this was a technology demonstration of pattern recognition in space, quite successful. The example we used was cloud masking computation on hyperspectral image, and that was demonstrated to be really successful. Just a word about our program, commercial program, which is called InCube, which is the program that we run at the PhilLab, and that is a co-founding program to help entrepreneurs to enter into the market with innovative commercial viable product. Finally, I want to give just a sense of what will happen to the PhilLab. So, as has been indicated into the ESA Agenda 2025 that has been published in March, the PhilLab will become the PhilLabNet, so a dynamic network of PhilLab across ESA and across Europe. So this concept will be expanded European-wide. So now I will finish just inviting you to participate to the Phi Week that will be starting on Monday. So, and I will really encourage you to listen to the opening session and to the DG, the Director General speech, because there will be interesting announcement. And if you want to learn more about PhilLab, you can visit our website. Thank you very much. And I give back the floor to Gabriele.
Thank you very much, Giuseppe. Very inspiring talk. And we are very much looking forward to the Phi Week next week. So I think now we have Domenico Mignolo. So Domenico, if you want, you can start.
Yes. Good morning, everyone. Can you hear me and see me?
We can hear you and see you.
Yeah, okay. I'll share my screen. Is that okay?
We see this in the wrong format. If you
okay.
suggest F5.
Yeah, sorry. Stop sharing. Is it better now?
Yeah, much better. Fantastic. The floor is yours.
Thank you, Gabriele. So, good morning, everyone. So the presentation will be basically dealing with satellite communication, and in particular, what are the activity on AI related to the ARTES program. As you know, the ARTES program is the program of the European Space Agency with the mission of improving the competitiveness of ESA member states stakeholders, so industry and academia. So AI basically is certainly a game changer for the future satellite communication. And as you might be aware, satellite communication is currently undergoing a major transformation, and AI is still at the infancy, let's say, but we already see in ARTES some activities, both fully funded by ESA, but also co-funded by industry. So the level of investment in AI for the satellite communication is certainly growing in the coming years. And in particular, there are three axes where we see AI, let's say, with impact. One is sustainability, because obviously from what we've seen in these 2 days, certainly will contribute to a green economy, but also support the adoption of sovereign data policy and foster sustainable practices, management of space debris, preventing failures, and so forth. So, but also will boost disruptive technology and enabling new services and application. And important that terrestrial solutions, so-called spin-in, will also merge with space solution and still improving the level of technology, but also application. There will be a support to fast decision-making and also the risk reduction. But we don't have to forget that in the end, the satellite communication serves a commercial and institutional market where the end user is probably certainly the most important part of the value chain. So AI will enable new business models, and we are also seeing a paradigm shift from production to consumer to everything as a service. And certainly AI will be contributing to an improvement in the quality of experience of the end user. And certainly, this is also due to the fact that we can extract value from big data. We can have improved performances, profiling, and also, let's say, customization of application to the user needs. So what is the vision for the future? The vision is that AI will be basically the brain of the system. So in a typical satellite system, we have the space, we have the end users, we have the ground controlling the system. And AI will be basically, let's say, in a very autonomous way, managing the system, taking decision. And the full system can be seen like a dashboard where every part will be as a function accessible by the user and by the service provider as a function. We also see the possibility of merging multi-domain applications, Earth observation, navigation, telecommunication. So in line with the vision presented by Giuseppe before, where data will be coming from different systems in a kind of end-to-end systems and providing value to the end users. But also, most important, that we have seen this with the emergence of 5G, that space will be integrated with terrestrial services and infrastructures. So the benefits, the AI will have an impact on both upstream and downstream. So on the upstream, certainly will contribute to the reduction in OpEx, inefficiency, like efficient use of resources like the spectrum, but also in reducing the risk and enabling autonomy. On the downstream, the major improvement will be in offering a better service to the end user in terms of service continuity, quality of service, but also time reduction for the customers, as well as cost reduction, because OpEx certainly and CapEx will be could be reduced thanks to the adoption of AI. And important, there is also the improvement in terms of security and reliability, which is certainly a must to be offered for the end users. So I reported here some examples of how AI could be applied on both upstreams and downstreams. So on the left part, you will see the technologies and products, and on the right part, services and applications. These are just examples. Probably we have to discover, and we will discover in the future, new application, new technology, and certainly the adoption of AI will boost, let's say, also the merging between technology and application. I reported here some of the functions in both upstream and downstream, and I will zoom in the next charts. So here, some example of technologies and products. So first, spectrum sharing and payload management. Certainly, AI will contribute to the optimization of the resources. We will have on board the self-reconfigurable payloads depending on the traffic needs and capacity. These will take decision and optimize the resource allocation, intra and inter-system spectrum sharing. Also with terrestrial network, in this case with 5G. We have autonomous operations, I think was already introduced by Gabriele. Certainly, autonomous satellite fleet management and control will be extremely important because we have seen now the emergence of constellation. So when you have thousands of satellites that have to deliver consumer services, it's very important that you optimize CapEx and OpEx, but also the service offered to those end users. So it will be extremely important to have autonomy, but also anomaly detection, classification, and prediction. Same for smart manufacturing. I think this is already fact that can accelerate the process and can improve the quality of the manufacturing. And interference detection and mitigation with the emergence of multi-orbit system, GEO, MEO, LEO, integration with terrestrial, certainly interference will become an issue, and AI will contribute to detect, to avoid, classify, and mitigate the interference. So some other examples on technology and products. Self-organizing network. Basically, the system in the future will be capable to be self-reconfigurable, self-diagnosis and self-healing, and to have a possibility to have inter-system orchestration and deploy as you go. Smart link allocation. We know that predicting link condition is a must if you want to have an efficient usage of resources, but also a good quality of service. And we see that AI, certainly with some smart allocation techniques and congestion prediction, can help. Future is also, there is...
Domenico, if
yes.
we need to wrap it up. I give you 1 more minute, but...
Yeah, okay. I've
been running late. Yeah, thanks.
So, yes. And for the autonomous vehicle, for data processing distribution, this will be certainly important. In terms of application, the AI will fuel the digital and green economy, transition to the digital and green, new application, new business models. Here, some example will help in law enforcement, detection of frauds and illegal activities, reduction of carbon footprint with the improvement of flat trajectories, for instance, in the energy sector as well. And in safety and security, as I said before, food and agriculture with precision agriculture services improvement and access. So we have really a lot of applications where AI could play a major role. And finally, in ARTES, we are already running several activities. That's my last slide. So, but we decided to focus more on the digital transformation and green economy. So there will be a new ARTES thematic call, which will open in October. So in a few days, will be open. Proposal can be submitted by industry, addressing one or multiple teams, and AI, machine learning is certainly one of those. As you see, together with digital twins, sustainable mobility, and green value. Initiative is industry-driven, so you come with your own idea, your own technology, product, or application, and will be co-funded. There is a single entry point, which is a pitch questionnaire, and there are 2 open windows. One is from now up to March, and the other one is from April up to November. I'm the contact point for the technology and products, and my colleague Rita Rinaldo is the contact point for applications. And important, next week there is the Space to Connect, which is the ARTES conference, where we will dig more into the detail of digital and green, the opportunity, and also in general final presentation of the ARTES activities. So thank you, everyone. Gabriele.
Fantastic. Thank you very much, Domenico. Thank you very much, Giuseppe. Very insightful talks and a lot of interesting announcements being made.